Hello and welcome to this tutorial for Amazon Lumberyard. Now this tutorial is sort of a follow-up or replacement to the previous tutorial, which was all about making these pipes move across the screen and then they would loop back around. That's all well and good. The problem is we used FlowGraph for that, and FlowGraph is fine for now, but it's on its way to being completely deprecated and removed from Lumberyard entirely. So they really want people using the Lua scripting. So I'm going to show you how to do exactly what we did last time. Make the pipes move across the screen, snap back, move across the screen, snap back with a random Z height. But we're going to do it with Lua scripting. So we're going to start off by right-clicking this and removing that flow graph. So push yes. Now there is no flow graph anywhere on those pipes, so they don't move. So we're going to instead add a Lua script component. And the Lua script component has this network bindable. Don't worry about that. Properties, which has nothing in it because there's no script, and the script. So the script, you could either load a script or you can open a Lua editor and create a new one, which is exactly what we're going to do. So we're going to create a new script. We're going to stick it in the cache, samples project, PC, samples project, scripts, and we're going to call this Flappy Pipe. Now, first thing you need to do is this. You need to put the name of the script with two brackets, and you need to put properties with brackets like this. Now this is just the format that it expects every script to have. This is what they call the table. If you don't have this and you just try to put code like debug.log or whatever and then say hello, it will not work and it'll yell at you. You always have to have this and this word here, flappypipe.lua, flappy pipe down here, needs to be exactly the same. That's what they call the table. So we're going to use that because every function we're going to write uses this format. You put function flappy pipe, so the name on activate, and then every function has end. So we can do the same thing with the on deactivate, and just like that. So every function is going to be like this. They all use the table name. Luckily, there's a little handy thing that if you do that, you'll see that it's all spelled correctly. We're going to add a third function here in the middle called onTick. And don't worry about this. We're not really going to use these very much, but these are just what it expects to have as parameters. So onActivate and onDeactivate are pretty self-explanatory. It's basically when the script loads and when the script unloads. In this case, it's going to be when we start the game, end the game. And onTick, which uses the delta time and time point parameters, is going to be called basically every frame. But the onTick function is a little unique because we need to set it up. So the first thing we're going to do is self.tickBusHandler equals tickBusHandler self. And in the deactivate function, we need to disconnect it by going self.tickBusHandler disconnect. So that's just something you need to do every single frame. You don't have to put these semicolons unless you really want to. I like to put them sometimes I don't. It's just sort of a preference thing. Good to be consistent though. So this tickBusHandler, this is a variable. So self dot, not capitalized, tickBusHandler is a tickBusHandler. Notice the caps, which we give it the variable self. So this is basically adding a tickBusHandler to this script, and then that's going to call onTick every frame, and then onDeactivate is going to disconnect it, which is just good to do that when you disconnect it, because onDeactivate doesn't necessarily get called when you unplay the game. Sometimes you disconnect it or call onDeactivate when the game's still running, so you don't want this constantly running if you're not using it. So that's pretty cool. onTick is going to call every frame. We could put a debug log in here to demonstrate. So this will now, what we were trying to do, will actually work. If we play this and we go flappy pipe and it gets all squiggly and doesn't like it, so you add it a second time, you can see every single frame it's going to call that. So there's kind of a weird quirk going on, at least with my particular installation of Lumberyard. This is something that was happening to me in 1.6 as well as 1.7. If I make an edit to the script, it doesn't seem to reflect it when I go back into the editor. So every time I have to remove the component, make sure that it's removed, and then I have to add the script again, and then it will actually like recompile the script. So I'm going to try to change things as little as possible. So I'm going to be writing code more and trying to explain it rather than stopping every single step and doing it. For now, I'm just going to delete that because we don't need it. I'm going to start adding some properties. So these are going to be a lot of the stuff we were doing in the previous flow graph tutorial, but we're going to do it through code instead. Properties are really nice because properties are something you can edit over here in the editor without editing the script. So if you're like me and your script doesn't seem to like to compile and you have to remove the component and re-add it every time, these you can edit in the editor and it will reflect the changes when you're running without having to edit the script, so you don't have to do that whole thing again, which is really cool. So every single property will have this, its default value. However, there's a couple extra things you can put if you want. You can put a description, which is just when you mouse over it, it'll say what it is. So we're going to say how fast the pipe moves. And you can also add a suffix, which is basically units. So we're going to make suffix equals meters per second. And that'll just be a thing that it'll fill out in case that's important to you. This is just a demonstration. I don't really need this that much, so I'm just going to go ahead and start adding the new ones. Now as you're writing code, make sure that you double check your errors. You have to put the default equals or else it gets mad. That shouldn't be a minus, that should be an equals. So this is the random min, random max from our flow graph, and we're going to have the same numbers as a default. Now we're going to add a couple more that were not used in the previous one. We're going to do loop y equals default equals negative 35.0 and time delay equals default equals 0.0. So this is the thing that causes it to wait a little bit if this is not 0, and this is the thing that's going to make it how far it goes before it loops back around. So both of those were used in the previous script, but we're going to be using them slightly differently in the script. So now that we have that, let's do that. Save it, remove it, double check that it's gonzo, script. Now you'll see the properties have appeared. So this is the thing with the properties. You can see the suffix, no matter how you change this, the suffix remains, and if you mouse over it, it shows you your description. So none of these other things have that, which is fine, because they're sort of self-explanatory, but if you're on a big group project with a lot of people, you probably want to have those. So let's start actually making this stuff do stuff. So Lua does something called the eBus system, which is you basically connect to components and then do stuff and send messages. So everything component, whatever, has a bus handler or bus sender. So one of the buses that we're going to be using is the self transform bus sender equals a transform bus sender, and it's going to be self dot entity ID. So we're going to create another variable which is called transform bus sender, which is a transform bus sender, and it's the bus sender of the entity that this is attached to. So this is the entity ID, 16979, a bunch of numbers. So if you did self, it would be the script. The script does not have a transform, so that's incorrect. You have to give it the entity ID. That's basically giving it the game object. And we're going to use that by going local transform. So we're creating a local variable. This is not anything to do with the bus or anything. This is just a vector variable that we're making. Transform, which is going to equal self.transform bus sender. So it's the name of the variable, not the transform bus sender. And we're going to get world tm. So this is just giving us our location in the world. And we're going to use that in a little bit, but first we're going to assign some variables. So these are variables, just like properties, you can use them anywhere in the script, but they're not editable in the editor because we don't want them for that purpose. 0, self.zpos equals 0.0, self.finishY equals 0.0. So you can notice these don't have semicolons, these have semicolons. You can put semicolons or not. I would stay consistent, so I'm going to put semicolons, but you don't necessarily have to. You can also put these on the same line if you want to be efficient with your space, but then in that case you do have to put the semicolons. I don't like to do that. We're going to add one more variable, which is self.timer, which is going to equal self.properties.timeDelay. So you can see we're now calling one of our properties, and you have to do that by going self.properties.timeDelay. So the difference here is these are variables we're assigning at runtime. These are just self.variable name. Properties are always self.properties.variable name. So that's important, so make sure to keep track of that. Finish is currently set to 0. We're going to assign that to something else, y, which is going to equal transform. So we're now calling this local variable get translation. So we're getting this x, y, and z as a vector, but we only want the y, and we're going to add properties.loop y. So the finish y is going to be the number. Remember in the previous flow graph we had this add vec3 and we minused 35 or whatever. This is basically what we're getting. So we're getting the world translation, which is going to start at 90 when we start running currently, and then we're going to get that y value 90, and we're going to add loop y. However, loop y is a negative, so it's actually going to subtract it, which means we're actually going to get 55. So this finish y is the number we're going to use. Y is going to constantly decrease every frame, and then we're going to check if that's less than finish y, so it's less than 55, and then we're going to set it back. So that's all we need in the onActivate. Everything else we're going to do in here is now on tick function. So the first thing we're going to do is we're going to make use of that timer minus equals delta time. So delta time is just every frame. It's going to minus delta time, which is the difference between frames. So that's going to be like 0.003 or something, but it's going to calculate it based on how fast the game is running. So it will be actual time rather than some arbitrary number. However, here's something important to note. There is no minus equals. So there is equals self.timer minus delta time. If you're used to C++, you might be tempted to use a lot of this kind of stuff. Can't do that. You have to self-timer equals itself minus delta time. If self.timer is less than 0.0, however, you can do less than or equals to 0.0, then end. So this is how you do if statements. If, put the statement in brackets, then, and then it ends with an end. Local entity transform y equals self.transform bus sender get world tm. So we're using exactly the same thing here. You can check to make sure it's all spelled right by doing that. We only use this in onActivate. We're using this every frame because we need it, and we have to assign it every frame because world tm is not going to be the same every frame, so we can't just do it once and then use that. And we're going to assign another local variable, which is going to be translation z equals entity transform y dot get translation. So it doesn't really need to be translation z actually. So local translation equals get the translation. So we kind of went a little bit not as far as this. So finish y, we got the translation, specifically the y. And this one we're getting the entire vector because we're going to be changing the whole vector, not just using one of its axes. So these are going to get set to 0 because most of the time we want these to be 0 because these are our difference between our y every frame and our z every frame. And mostly these are going to be 0 except for when we go if translation.y is less than or equal to self.finishY. So in this case, these are going to be something other than 0. So self.y pause equals negative self.properties.loopy self.z pause equals math.random. This is a function that comes with Lumberyard, so you're getting a random number. Properties, make sure that's capital. You know it's right if it's highlighting everything else. dot random min and self dot properties dot random max. So we're getting a random number between currently -5 and 0, unless we set those to something else. And just like we did in the previous flow graph, we're going to round it to the nearest integer. And the one last thing we're going to do is translation dot z equals 32 plus self dot z pos. So 32 is just because it starts at 32. It's not starting at 0, otherwise we would probably have it at 0. And this probably would be a variable that we store. I'm not going to worry about it right now. And now that that's taken care of, we're going to do this every single frame. So we're out of this if. So this is just basically adjusting the thing whenever we get to the point where we want to reloop. This is going to happen every single frame regardless. So we're creating a new position, which is translation plus a vector 3, which is always 0 in the x because we're not moving forward or backwards, we're just moving left or right. And it's going to be self.properties.move speed plus self.ypos. So you can see that self.properties.movespeed is -0.1 meters per second, and we're adding plus self.ypos, which is usually 0, but every once in a while it's going to be a positive because this is negative, negative, and negative. So this is going to be plus 35. So we're going to loop it back around and then start going again. This is going to be 0 because we're not adjusting anything in the z in this vector. We've already done that. And then we're going to entity transform y, set translation to the new pos. So we're basically telling it this is the new translation. And we're going to set world tm. And we're going to give it that vector. So every single frame, we're going to minus this from time delta time. This is just for the time delay. If that's true, and we're less than 0, which means go, we're going to get the position in the world. Then we're going to create these two variables. If we're far enough to the left, we're going to add an adjustment to the y position and the z position. And then we're going to create a new vector, which is going to be minus move speed. And then if we have to reloop, we're going to add some y and then add a random z. And then we're going to add it to the pipe every single frame. So I'm going to save, move the component, do the thing. Hopefully you don't have to do that. Lua script, flappy pipe. And have it give an error. So if you do have an error like I just did, it's going to tell you the name of the script, and then it's going to tell you the line number, which is really useful. So in this case, I have an error somewhere because I forgot to put equals, which is not good. So new position equals translation plus different vector. All right. There we go. Here's all our stuff. So now if we run the game, there it goes. Now we can see it's looping, and it's looping randomly. Although sometimes it hits the same number, so it's not always, we don't have that big of a range. Right on. Now this is the cool thing too. We have all these properties set up. If we decide that the pipe is moving a little bit too fast for our sake, we can cut that in half. If we want to put a bigger range than that, maybe do something like that. We can do all those edits in the editor without having to go into the script. So now the pipe is moving half as slow, and it's going to have a wider range of motion up in the Z position. And of course, in that case, it's going to go over the line, so we could fix that by just making the pipe longer in whatever direction, which we might do later. But for now, we got rid of the flow graph and made it a Lua script, which is a good place to be, because flow graph, like I said, is going to be completely obsolete, so it's good to learn Lua script sooner rather than later. So thank you for watching, and I hope that was useful.